All right, we're about to dive into a really fascinating and honestly powerful idea in the world of AI. We're talking about a way for artificial intelligence to get smarter without ever actually seeing the raw data it's learning from.
Yeah, it sounds like a total paradox, right? How in the world can you learn from something you're not even allowed to look at? Well, this is one of the absolute biggest challenges in AI today, and we're going to break down the brilliant solution.
At the heart of this whole thing is a fundamental conflict. To build really powerful, helpful AI, you need just massive amounts of data. But the most valuable data, the stuff that could lead to huge breakthroughs, is almost always the most private.
Just think about it for a second. We're talking about your personal health records, your company's secret sauce, all the activity on your phone. It all lives in these secure, scattered out places. You can't just hoover it all up and move it to one central server for an AI to study. That would be, well, a disaster waiting to happen. It's just way too risky.
So, if we can't bring the data to the model, what if we bring the model to the data? This is the core idea behind something called federated learning. And it's such an elegant solution that it basically flips the entire traditional training model right on its head.
And you can see the difference so clearly here. The old way meant putting everything in one big pot, which, creates this huge, tempting target for data breaches. Federated learning, on the other hand, keeps the data exactly where it's supposed to be: local, private, and safe.
Okay, so how does this magic actually work? Well, first, each device, and that could be a phone, a hospital server, whatever, it trains a small AI model on its own private data. Then, and this is the key, instead of sending the data, it only sends the learnings, these little mathematical updates, to a central coordinator. That coordinator then aggregates all these lessons from everyone to build one super smart global model, which then gets sent back to all the devices. The most important part, no personal records ever leave their original home.
This mantra just captures the whole concept perfectly. The training happens in private, on your local device, but the intelligence that's gained from it is shared globally so that everyone benefits.
And the benefits here are just massive. This solves the nightmare of trying to train on regulated data, like in healthcare or finance. It lets different organizations collaborate without ever having to expose their sensitive info. And, it's a foundational piece for building AI systems that we can actually trust.
Okay, so this seems like the perfect solution, doesn't it? The data never moves, problem solved. But here's the plot twist. What if those mathematical updates that get shared could somehow, be reverse engineered to reveal something sensitive about the original data they came from?
And this is the critical follow-up question, right? If we want true privacy, we have to protect not just the raw data, but the lessons learned from that data too. So, how do we do that?
And that brings us to the next layer of the solution: encrypted AI agents. Now, this is where things get really, really cool. We can use advanced cryptography to wrap a powerful shield of security around the model updates themselves.
These agents are incredible. They use these wild techniques like homomorphic encryption, which basically lets a system do math on data while it's still encrypted. Think about that. It means the model can combine all the updates without ever being able to actually read what's inside them. It's complete privacy.
Let that sink in for a second. The AI agent is, for all intents and purposes, blind. It is working with information that is completely unreadable to it, and yet it can still do its job and create a smarter, more accurate global model.
It's amazing.
The source material had this perfect analogy for it. Imagine a teacher who has to grade a whole stack of tests, but every single answer is blacked out, and yet somehow they can still calculate the final correct class average. That's the kind of magic we're talking about with encrypted AI.
So, what happens when you bring these two powerhouse ideas together, federated learning and encrypted agents? Well, you get a truly complete, secure system. Let's take a look at how that works.
This is what we call privacy-preserving AI, and it really gives you the best of both worlds. You get privacy because the data never leaves its source, that's the federated learning part, and you get security because all the shared updates are mathematically scrambled. That's the encrypted agents part. It's a 1-2 punch.
Okay, let's make this super concrete with a real-world example. Imagine you have several research labs scattered around the world. Each one has super valuable patient data. They all want to collaborate to build one world-class AI model to detect heart disease, but privacy laws like HIPAA make it impossible to share any patient records.
Here's how they do it. Each lab trains a model locally on its own patient data. Then, they encrypt the model's learnings and send just those encrypted updates to a central aggregator. That aggregator, using homomorphic encryption, combines all of the unreadable updates. And the result? A single, powerful, improved model for detecting heart disease is created, and not a single piece of raw patient data ever had to be exposed.
And that's the ultimate goal, isn't it? This allows for incredible scientific collaboration on some of the world's toughest problems, without ever having to compromise on our fundamental right to privacy.
You know, that idea of collaboration without compromise really leads us to a much bigger picture. This isn't just some clever technical trick. This combination of technologies, it represents a profound shift in how we think about building AI systems that all of us can actually trust.
For the longest time, there was always this trade-off. If you wanted top-tier privacy, you pretty much had to accept that your AI model's performance would suffer, or it wouldn't be able to scale. What this shows us is that we don't have to make that choice anymore. We can finally have both.
So the future this opens up is one where AI is inherently respectful of our data. It's secure by design. It's ethically decentralized, because it's all about sharing intelligence, not hoarding data. This is how we build an AI the world can actually trust.
And I think this is the crucial takeaway. Real, true innovation in this field isn't just about making AI a little bit smarter. It's about fundamentally rebuilding it so that trust is baked in from the ground up into every single layer.
So I'll just leave you with this question to chew on. Now that we know we can achieve both incredible intelligence and ironclad privacy, what new doors does this open? What problems that we used to think were impossible to solve are suddenly within our reach? The possibilities are pretty exciting.